Hello guys, in this class now, let's now talk about the multiplication of matrices. So there are two types, normal multiplication and your scalar multiplication. Now, two matrices A and B can be multiplied by multiplying the row of the first matrix by the column of the second matrix. Two matrices A and B can be multiplied when you multiply the row of the first matrix by the column. The rows by the what column? I'm going to explain that. I just want you to master the definition. Two matrices A and B can be multiplied by multiplying the entries of the row by the entries of the what on the column. But this is not just the main thing. This is where the exam question is. What is now the exam question? They will ask you, we know that for addition, two matrices are compatible for addition when they have zero and column. But in multiplication, it is not so. For two matrices to be multiplied, this matrix must fulfill this criteria. And what's the criteria? Take note that two matrices are compatible for multiplication. If the column of the first matrix is equal to the row of the second matrix. If the column of the first matrix is equal to the row of the second matrix. Now, let's process that. This is where the exam question is. You don't need to flop in it. This is where it is. You will see it in the exam. I beg you in the name of God. Please hold it. I beg you. When is two matrices said to be compatible? When the column of the first matrix is equal to the row of the second matrix. Now, let's explain that. I write in matrix now. A matrix A was given as M times N. And another matrix B was given. Now, M is the row. N is the column. I is the row. J is the column. For me to multiply these two matrices, A and B, for me to multiply this matrix A and B, the number N must be equal to I. Remember that N is the column, while I is the row. The column of the first matrix must be equal to the row of the second matrix. If N is not equal to I, they are not compatible for multiplication. The column of the first matrix must be equal to the row. The column of the first matrix must be equal to the row. The column of the first matrix must be equal to the row of the second matrix. The column of the first matrix must be equal to the row of the second matrix. The column of the first matrix must be equal to the row of the second matrix. The column of the first matrix must be equal to the row of the second. Column of the first matrix, I beg, is the exam question. Should I kneel down? I've been teaching for years. The column of the first matrix must be equal to the row of the second matrix. Now, this is past question 1. You can now twist it. What will now be your answer? Remember that when are they compatible? They are compatible if N is equal to I. That means if this guy is equal to this. They will now ask you, what will now be the result of the matrix form? AB that we form will now be equal to what is left? M is left. What's now left? J. So this is what we check. This is for compatibility. This is what your answer will be. This is the result. So if they ask in the exam, they can ask you, what will be the results of the matrix? Or what will be the compatibility? Compatibility N must be equal to I. The result is what is left. Do you understand that? Now, if you say you understand that, let's take past questions. The past question says that if a matrix M times N, a matrix A, we're giving that the matrix A is what? An M times N matrix. Is an matrix B P times Q matrix. When is BA conformable for multiplication? Now, it's not AB, it's BA. AB is different from B. Now, okay, let's do that. Let's do for BA. BA means we are bringing B first before A. So, what is the criteria? The column of the first matrix. What was the first matrix here now? B. What was the column of the first matrix? The column of the, for BA now, the column of the first matrix is Q. So, it now means Q must be equal to, what's the rule of the second matrix M? hold on a bit. As far as 100 level is concerned, right, for both first and second semester, your complete series of classes, including your practicals, everything from beginning to the end is in the LearnLift app. All you have to do is just march down to your Play Store or App Store and download the LearnLift app, and then you're going to have access to every singular class. So just move down to tertiary, click on tertiary plan, where you are going to see all your classes as far as your 100 level is concerned. And guess what? Your video lessons are there, your CBT is there, you have access to your past questions, you have access to your notes. Very, very important. Man, this semester, you must do well. Anyway, let's proceed quickly as we march down to our class and continue our class. Enjoy. Making option B to become the answer. So, this is when they are compatible. So, what will the result be? Remember that we have carried Q, we have carried what? N. So what will the answer be? The answer will now be, remember that this is for compatibility. Compatibility. What will now be the result? The result will now be what is left. Remember that we have removed Q and we have removed M. So what is left is N and P. Between N and P, who is 0? P is 0. Right? So it will now be what? A P by N matrix. Now, what of if it's an AB? AB. That's AB. For an AB, what we did for a BA? For an AB, it means A is coming first. What is A? A is an M times N matrix. And what is B? B is a what? P times Q matrix. The colon of the first matrix, what is the first matrix? A, because they say AB. So the colon, that's N, must be equal to what the column must be equal to the row, that's P. This is for compatibility. What will be the result? What's left? M is left, that's it. That will be an M times. Remember that you have carried M and N, so M times Q. This will be the word, the results. This one is the result. Please know when matrices are compatible. The column of the first matrix must be equal to the rule of the second matrix. The column of the first matrix must be equal to the rule of the second matrix. The column of the first matrix must be equal to the rule of the second matrix. The column of the first matrix must be equal to the rule in there. Now let's take another question. We're giving two matrices. It's a past question. We're giving two matrices. A is equal to Aij of order R times S, and B is equal to Bij of order P and Q. When is it conformable for what multiplication? First, the matrix was given as A is equal to Aij, which is a what? R times S matrix. B was given as B, which is equal to Ij, that's row, and column is given as P times Q. They ask you when is it compatible. That means they are referring to what? A and B. Are you with me? So if it's not AB, they will state it. So for AB now, what's coming first? The column of the first. This is the column, Abi. IS must be equal to the what? The row. S must be equal to P. So what will now be the matrix? What's left? This is for compatibility. What will be the result? The result is that R times what? Q. This is what the result will be. Please, we have solved two past questions. Now, only you do for BA. What will BA give me? One who is BA compatible. First of all, what's B? B is equal to what? P times Q. What is A? A is equal to R times S. So what will now be BA? What is now BA now? Column must be equal to row. That means Q must be equal to what? R. This is for compatibility. What result be? What is left? P and S. So P times X. That will give me for what? Result. Hope you see it's not the same as this. So at every point, know whether they're asking, are they finding A, B, or PA? It depends. Now, if you say you understand that, in our next class, we'll start normal matrix multiplication. I'll see you in that class. Peace out. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.